Tutorial sheet 3, question 2. We're given this equation for an FM signal, which is 10 sine 10 to the power 8 of t plus 3 sine 10 to the power 4 of t. We're asked to calculate three terms for this. First of all, for part A, we're asked to calculate the carrier and modulating frequencies. So we need to compare this to the standard form of FM. So that's the standard form of FM. So we can clearly see that omega c is equal to 10 to the power of 8 and omega m is equal to 10 to the power of 4. So omega c, which is equal to 2 pi fc, is equal to 10 to the 8, and omega m is equal to 2 pi fm is equal to 10 to the 4. Hence, fc, our carrier frequency, if we rearrange that, is 15.9 megahertz, and fm, if we rearrange that equation, is equal to 1.59 kilohertz. So that's part A. Part B asks for the modulation index and the frequency deviation. Well, just looking at the equation, the modulation indexes can be inferred from this. So the modulation index beta is equal to 3, simply from the equation. And we know that that has got to be equal to delta f over fm. We know what fm is now from here. Hence, delta f, our frequency deviation, is equal to 4.77 kilohertz by rearranging that equation. Part C asks to calculate the power dissipated in a 100 ohm resistor. Well, this is really simple because for FM it's very straightforward for power, because we don't need to concern ourselves with what's inside the sine wave. It's just a sine wave, and the sine wave has a maximum value of 1. So, and we know how to calculate average power in a sine wave. So the power dissipated is simply Vc over 2R. Remember, the 2 comes from the manipulation of the average power in a sine wave. So that is 10 squared over 2 times 100, because R is 100. And if you work that out, you get 0.5 watts.